How do you see Cohere supporting the startup ecosystem in Canada?
I think Cohere plays, and obviously it plays a pretty significant role. I think we're one of the bigger players in the scene. We have to show that it's possible to build a really, really ambitious project here. I think we are like an existence proof that you don't have to be, sort of in the valley to build something really, really ambitious. And not only do we have to be an existence proof, we have to, actually put in the time and effort to do what's necessary for the scene, right? Like not just sponsoring it, but also providing our space as a place for people to gather and make sort of these interactions and connections, sort of serendipity to happen.
What do you think could be a killer Gen AI application in a couple of years? Something that we're not even, really thinking about now?
This year's Disruptor 50 list is chock full of companies making breakthroughs in AI. Cohere develops natural language processing models that clients can deploy to build chatbots, search engines, and more. Cohere currently has strategic partnerships with Google and AWS.
I think the most exciting thing for me with this technology is that it sort of evens the playing field between everyone. So just because I spent a few years of my life memorizing how to build backend systems in Go, and my mom, who hasn't had the same amount of training in this area, us sitting in front of a computer, we should be able to accomplish the same thing. Hey, I'm Ivan. I'm one of the co-founders of Cohere, and I'm happy to be having this conversation. So I'm a proud Chinese immigrant, came to Canada about 20 years ago, went to computer science at the University of Toronto. That's where I met Nick and Aidan. And I actually dropped out of school. So my friend started a company in undergrad, and she raised some funding, and she decided, hey, why don't you come work for me full time? And I thought it would be a sort of a more better learning experience, just working on the job compared to staying in school. And so I just went for it, dropped out, worked a few years at startups, just building sort of back-end systems. Eventually, I caught the startup bug, and that's when I messaged Aidan. I was like, hey, we should try to start something together. And at that point, we were already a few years into doing 4AI, which is this independent research group that now we've brought onto Cohere. And so obviously the space was going to be AI. We thought there's something sort of there. He did the transformer. And so he thought, oh, why don't I just scale up this architecture? At the time, Google didn't really have the ambition to do anything with it, except, obviously improve search. But we sort of saw it as a moment where, hey, now computers can actually communicate with us and also understand us. What kind of interesting software could we build now that sort of silicon has this capability? So it seemed obvious to sort of take the leap and start Cohere.
Why didn't Google want to do it themselves? That's a very interesting observation that you made.
Honestly, it's a textbook example of the innovator's dilemma, right? You have this very, very profitable, 90% margin business, which was search. It's really hard to deprioritize anything from that to actually invest in something, completely net new, which was this new sort of interface or this behavior that computers have. So, that's not the case now, right? They're sort of very focused on this space. But at the time in 2019, there was no interest whatsoever.
So how has your role kind of grown, since the beginning? Because obviously you've been there right since the very beginning, and now Cohere is this huge global enterprise. How has it changed?
Oh, man. I mean, I've worn so many hats while I'm here, and that's sort of what I expected. At the startups I worked at before, that was a very sort of normal thing. When you work at a startup, you're expected to just roll up your sleeves and just do sort of whatever it takes to make the business succeed. And so when I started, I was literally just setting up Kubernetes clusters to, crawl data to train the first version of our model. And then at some point I managed the product team. At some point I managed the business operations team. And, honestly, I think the role of the founder is sort of to fill these gaps, where the business sort of needs you until you can hire, operational leaders to sort of take that on. And then you move on to the next, impactful thing. And so, More recently, I started the sort of synthetic data team, and now I'm moving sort of back to like this engineering role.
How do you see Cohere supporting the startup ecosystem in Canada?
I think Cohere plays, and obviously it plays a pretty significant role. I think we're one of the bigger players in the scene, and Shopify being sort of the other, big prime around here. I think we have to show that it's possible to build a really, really ambitious project here. I think we are like an existence proof that you don't have to be, sort of in the valley to build something really, really ambitious. And not only do we have to be an existence proof, we have to, actually put in the time and effort to do what's necessary for the scene, right? Like not just sponsoring it, but also providing our space as a place for people to gather and make sort of these interactions and connections, sort of serendipity to happen. So I think we play a big role, but I think we're not the only player.
Yeah, that serendipity thing's really interesting because, I think a lot of us kind of downplay the role of serendipity in building startups, but that makes you kind of think, oh, is it quite a random process? But how do you handle setbacks, like when you've tried something and it doesn't work?
I mean, setbacks in general, you just sort of take it on the chin and you learn what you can from it. It's also, it's tough to sort of identify what you had control over and what you didn't have control over, right? And obviously, the thing to learn is, what did you have control over, and sort of say, okay, how could I do this next time when I have the same sort of control? So, yeah, I mean that's just more general advice, I guess, on how I look at setbacks.
Very interesting. So, what do you think could be a killer Gen AI application in a couple of years? Something that we're not even, really thinking about now.
I think it'll be a product or a feature that's sort of built into a product, where you don't even notice that it's AI. Like I kind of see Gen AI as like a component of an overall system. And I think beautiful products sort of hide the components away from the user. Like they don't have to think about it at all. And so interacting with it should be very natural. It should be either, like you're interacting with a friend and you don't even think that it's sort of this AI thing under the cover, or it's sort of an existing workflow that is now much, much easier. And you barely notice that it's like, a reasoning engine under the covers, making your life easier.
Yeah, I really agree with that. I think since the beginning of the deep learning revolution, we're seeing the level of abstraction increasing. So at the very beginning, you needed to know about, CUDA and compilers and hardware, and then it was PyTorch, so software engineers could get involved. And now the abstraction is increasing even more to kind of, applications and agents and so on. And do you think there might be a kind of breakthrough level of abstraction where we really build completely different applications?
Totally. I think that's sort of why we focused on embeddings very early on. I thought it was very, very important to sort of create a data type for the computer to just like map a language to sort of these discrete processes. And I think the interfaces that people will build, giving Silicon this capability to just totally understand you end to end. I think that's going to unlock so many new interactions that people will have.
Yeah, it's so cool because now just using language, we can generate code, we can build these systems. But I find increasingly I'm building kind of, agent-based systems using the actor model. And the systems are they're of a different character than the kind of software we used to build before. And kind of that's okay. But I don't know, I guess it's a different way of thinking about software that enterprises are going to slowly adopt.
Yeah, and I think the way I've seen people build software companies has changed as well. I met this founder the other day, and he was actually building up a repository of like chat logs with AI assistants. So his team has to actually share sort of all their, chat histories working through technical problems. And there's just now a repository of like, oh, how did you solve this before? Oh, I had this conversation with, this assistant. And that's sort of now like a shared like repository of knowledge that, his humans can actually look at and, do the job better.
Yeah, and it's so fascinating that we're building with behavior rather than instruction, if that makes sense. I guess it's still both. We're instructing the language models to do things, but usually it's different components interacting with each other, and then we iteratively refine. So we say, okay, well, let's see how this thing behaves. I like that. I don't like that. So I'm going to refine the behavior, and I'm going to rinse and repeat. And then eventually we converge on a system that does the thing we want it to do. And that's just really, really fascinating.
I don't think it's that much different before AI, right? I think the sort of iterative feedback process, we used to sort of just address feedback by literally writing the code to sort of change how the system behaves. Maybe this feature doesn't work quite right, like we'll just change it. With AI, I mean, it's the same sort of process. It's much easier because now the computer is totally steerable with language. So rather than, writing Python or JavaScript, you're sort of just describing what you want. And yeah, the agent will sort of either behave differently or help you change the code to change your system.
Yeah, I mean, it's like I've got this software that processes all the MLST transcripts. And now I can get it to do crazy stuff. I can say, every time Ivan makes a mouth smack, I want you to put it in the transcript. And every time he does this, I want you to put it in the transcript. And it's all just generated. And then I might detect a situation where you made a sound or there was a distraction which I didn't specify before. So I just add it in. And it's just this really rich kind of process. And the amazing thing is, like, you just can't I mean, how would I have written some software to do audio event detection before? It just boggles the mind. Whereas now I'm just kind of saying what I want it to do, and I'm just iteratively building it.
I think the most exciting thing for me with this technology is that it sort of evens the playing field between everyone. So, just because I spent a few years of my life memorizing how to build backend systems in Go, and my mom, who hasn't had the same amount of training in this area, us sitting in front of a computer, we should be able to accomplish the same thing, right? If I wanted to write really, really good distributed systems, I think, my mom should be able to do the same thing in front of the computer, right? It's the same sort of piece of silicon. It has the same access to information, on the internet or, scraped on Common Crawl or something like that. Why can't we both sort of produce software or videos or photos that the computer could literally do if there's a different human sitting behind it?
Do you think that people hold language models up to an unreasonable standard? And what I mean by that is people say, oh, they're only sort of like 96% reliable and that's not good enough yet. But as you just said, in a way, it's no different to traditional software. So, when has software ever been reliable? And also, we're used to kind of reasoning about information on Twitter and in social spaces, and everyone has different opinions, and we're kind of doing inferences, and we're finding our own path in life. And how is that so different?
Yeah, it's not different. I think it's I see it really as another tool for creation, and I think unfortunately, it's sort of been marketed as this conscious thing that will take our jobs or, create bioweapons to make humanity extinct. But I think if you approach it from the lens of like, look, this is another tool to help me create things in front of a computer, I think that human in the loop aspect is important to reinforce because at the end of the day, it is about helping us sort of do our work better. So I think it totally should be viewed with a lens of, hey, this is a intelligent thing that needs our steer to actually be useful.
And what is your intuition about it not being an existential risk? I mean, for me, I love John Searle, and he made a very, very simple argument, which is that, agency and intelligence is a physical phenomenon. So he's not saying we couldn't recreate it in principle, but, the only existence proof is in the brain. And there is a difference between a simulating thing and the actual thing. So you simulate fire. It might have all of the behavior and, dynamics of fire, but it doesn't burn. there's a property which is missing. So for that reason, you can simulate intelligence until the cow comes home, but it's not going to have the actual physical phenomenon that we have. I mean, would you roughly agree with that?
I don't know. I think this technology can go quite far. I wouldn't say it's not possible to sort of recreate the human level intelligence. Personally, I think there are many limitations today that can be solved. There are some net new existential risks, but like other technologies that came before it, like the internet, like cell phones, like there's definitely ways that the internet has impacted society, right? Like it has changed how humans have behaved. So I think it's worth sort of discussing, what the AI risks are, but that should not be the only focus point, right? Like there's so much positive, productive value being created. I think that's worth focusing our energy on rather than only on the risks. I think we should discuss some of the risks, but not, that should not be all of our energy.
So there's been an exponential increase of demand for compute, just going back. And it would have been surprising 10 years ago if you said, look, we're just going to need so much more compute in the future. People might not have believed you, but now it's absolutely obvious. But do you think that trend will continue?
For my own interests, I hope, the costs will go down. But I do think that the cat's sort of out of the bag. Like the humans will want more and more flops in sort of whatever that form takes. I think it'll just be an exponential increase. Like the models will get better, then humans will want more of it. Then we need sort of the compute to actually power it.
How is Cohere differentiated from the other, kind of similar startups?
So we focus on training our models to behave well in these air-gapped, private and secure environments. So relying less on its internal memory and more so on, hey, you have access to these 4 or 5 or 20 or 100 internal knowledge bases. How do you solve problems in that sort of setting? And so we actually just train our model to do that. So we have human trainers who essentially act as this model with only sort of these internal knowledge sources that enterprises would have. Think sort of your HR systems, think financial accounting systems. And we only teach the model to be good at this sort of RAG setting where you can retrieve information, you ground on it, and you generate your answer sort of grounded on this external information that you haven't memorized.
So can you go into a bit more detail on Ragl? Because that seems to be one of the most powerful things that you folks have really, really optimized on. Like, can you give me an example where it's really kind of lifted an application up?
The most surprising thing that I saw was just this last week. We were talking to a team building software for doctors in hospitals. So the idea is they added this new feature. It's powered by Command R using this sort of RAG approach, where they would just sort of fetch the most recent patient records, so the doctors can actually look up, hey, I'm about to see this patient. Give me some materials to prep with, right? And so this tiny RAG feature that they built that should produce the summary about the patient reduced their prep time from 30 minutes to 5. So I think that's a very real example of like, hey, the AI is actually improving patient care, and in a way where it's sort of built into an existing workflow. The doctor isn't sort of learning this net new piece of software. It's like, okay, he's just doing exactly what he's about to do. It's just now that there's this little box that shows a summary, and it completely changed like how much time he should invest doing research on a single patient.
What's Cohere's approach to privacy and security?
So the nice thing about our approach is we send you the weights, right? Like our customers are just running our containers in sort of air-gapped environments where there's no there's no way for us to actually look at what you're using the model for. So all the usage data, you keep that. And obviously we have, sort of APIs and different ways to access the model, but the sort of end state is, hey, we're running on premise, we're running in these, private networks. Our model is just another piece of software, like a database that you manage and you can control the access for behind your firewalls. That's a very important part of everything we do. It's sort of, hey, like we can't just talk back to the internet. Like we have to behave well in sort of these lockdown environments.
Do you give your customers advice around, because this is still quite it's a complex technology, and even though they can control it, inside their enterprise, there are complexities that weren't there before. How do you help them with that?
Yeah, we provide a lot of advice. I think a lot of people are excited about Gen AI and they're not quite sure how to apply it in their organization. And so sometimes they even make too rash of a decision to, try to give their users, whoever they may be, maybe, internal employees or their actual, external customers, they might be giving their users something they don't even want, right? And then they're shipping AI and, their users don't know what to do with it. And I think the most general advice I've given so far, is just, hey, work backwards from the human, right? Like, what is the human doing today? And sort of see where it makes sense to add an automated reasoning process grounded on internal knowledge. And I think a lot of times it's sort of, it's just the human in the loop use case that makes the most impact. And then once you sort of get into your organization in a way that lets people, for the lack of a better word, play with it, then the ideas start flowing and people start, seeing use cases here and there that, and it really takes a domain expert to figure out where, this automated reasoning thing should be applied. I think it's been interesting seeing how adoption has happened in the past year.
Yeah, because I think one of the issues with GPU compute in the enterprise is efficiency. So strangely, the cloud providers, right from the beginning, they virtualized the CPU stuff, but not the GPU stuff. And people just created GPUs everywhere in random subscriptions all over the place. And clearly now we've got a problem. Right. And, these language models, they take up a whole load of GPU memory, and it's a real optimization problem to figure out, I need to have different versions. I need to have large ones. I need to have small ones. I need to have a model serving, architecture and so on. How do you help folks with that?
Yeah, I think, if you look under the covers of Kubernetes, it was not built with GPUs in mind. We spent a lot of time just trying to make even fractional GPU allocations work. I think it's there's a lot of pioneering engineering, unfortunately, but it's a lot of fun, of course, trying to solve these sort of hard problems. When we help with our customers, it's, hey, we've seen this problem before. Here's a container that does the same thing that you're looking for, or here's a manifest that you can run. Here's a Helm chart. That's the sort of thing with these sort of on-prem deployments. Everyone has, a slightly different setup. So it's slightly more hands-on. But we're sort of learning along the ways that, the things that make sense to generalize. But, we're certainly open to the fact that the market is still super young, super new. And so nobody really has it figured out. So some assembly involved to get things running.
Yeah, on that note as well, because I completely agree. I think that because of the complexity, every installation, every architecture will have its nuances. But then there's a bit of a consultancy trap. Not that consultancy is bad, because it's a great way to build amazing relationships with strategic customers. But how do you balance kind of having a real core offering that is as generalizable as possible versus doing some real targeted strategic, applications?
Building products is more nuanced than looking at it as, a consultancy or not, right? I think Obviously, you should not, or obviously, we're not building our business to become a services shop or a consultancy. But the reality is, the first time you build your product and you put it out into the world, it's very unlikely that that is the right manifestation without sort of being battle tested by user feedback, right? Without feedback, you're not going to build, the perfect feature set right off the bat. And so, for your first few customers, you're just going to have to work really hard to, change the product, customize product for them, so that they feel compelled to use you. And then from that experience, from that process, you can build sort of generalized features that apply to other customers. But I think it's naive to think that you can build a product like a V0 and have it be the perfect feature set that will apply for every customer. Like, no, like I think you have to work really hard, do the calls and installation many times, and just serve your customers, right?
Can you tell me about your relationship with the cloud vendors, how you're partnered with them, and also some of your partnerships with some of your top customers? I mean, what are people building on Cohere?
So we partner quite deeply with our, very, very public partners, and even for the private ones. Because the manifestation of Gen AI in the enterprise is so unclear, there's many tracks that we explore. So one way we've done this is, the first step is to actually just get the model into their on-premise system so that their employees could actually, use this thing to either build features to power their existing apps, build sort of new projects, or just even use it for their day-to-day work. And so think like, large enterprises, their HR team is completely enamored and swamped with questions every day. And now with an assistant that's sort of connected to, standard operating procedures and policies and stuff like that, could then be the sort of first draft to either answer a question or even as this tool to sort of search up sort of HR policies for the employees in a self-serve way. And obviously, we go deeper. If the enterprise needs more than that, we go deeper. So if there's some sort of behavior or some knowledge that's important to have in memory, we help the enterprise sort of build that into their version of the model, and that's a deeper collaboration, right? And obviously, every step along the way, we sort of help them think through, hey, is this actually useful for the humans that you're trying to serve? Because really, that's the most important part, right? Like that's how ultimately our customers will get value out of this technology. And so, for us, it's really important to think about the humans that they're trying to serve.
Absolutely. As a quick digression, didn't you have a gaming background?
I played a lot of video games growing up, yes, but I was never like a pro gamer or something.
But do you still game today?
Yes. It's one of the only ways to sort of get my mind off of work and just take like a tiny sliver of a break every day.
Yeah, absolutely. I've got a Meta Quest Pro, and it's so therapeutic. Even just putting it on and just being in the menu screen, I just feel like the stress melts away, and I'm in a different world entirely. But what are your kind of go-to games?
League of Legends is a big one. That's been a staple my whole life. Lately, I've gotten more into like Dark Souls type games, like Elden Ring or like Wukong. Something about just, trying like a really hard thing over and over again, and getting obliterated like 100 times to like a really hard boss. Like there's some peace I find in that.
Is there any crossover between what you do in the gaming world and real life?
Absolutely. I think it's taught me to just have high endurance staring at a screen for many hours. I think it's taught me the importance of teamwork, the importance of communication as well and not over communicating. I think at times, you hear this phrase like, hey, you should communicate more with your teammates. But sometimes if you communicate too much, it's actually noise, right? It's not helpful information for whoever's on the other side hearing it to make a decision. And so, not overloading the comms is sort of a thing in gaming where, if your teammate's going through a stressful, 1 versus 5 situation, like you don't want to overload them with information so that they could perform well. I think that very much so applies, in the real world at work. It's not particularly helpful to info dump every piece of information. You sort of have to, be a bit more intelligent in sort of what you share and when you share it.
Yeah, I used to be a big Quake Live player. And with strategy, what I noticed was 2 interesting things. Like, we think of it in terms of top down. So we try and create these global rules for everything. But what I noticed when experts were talking about the strategy was how situational it was. So it's like, in this situation, you should do this, and in this situation, you should do this. And sometimes it felt incoherent, which is kind of weird. So there's always this kind of tension of how can I cohere the top down with the bottom up strategy?
Yeah, you could have a grand plan of how the scenario is going to play out or how the game is going to play out. But really, it's sort of in the execution and in the micro details, in the situation that really determine the outcome. That is absolutely applicable to the sort of real world workplace. You could have a strategy for the quarter, but if the execution is not precise or you're not reacting to new information, things will not go well. And so I think that's something I've learned in gaming. Yeah.
Yeah, because I wonder how you manage that in your organization, because there must be an analogy in the sense that, a lot of people in an organization at different points can't understand each other. Right. And it's because in their situation, this is their model, and it might seem incoherent or even nonsensical when they kind of explain their view to someone else. And there are loads of different ways of overcoming this. But how do you think about that?
I actually think about it exactly like how I think about debugging language models. When the language model isn't behaving the way I expect, I just think about, okay, what did it have in its context, right? Did the search system retrieve the right documents? So is the model actually reading the right information? What is the model trained on? How has it been steered? What sort of feedback is it sort of reacting with? And so, given all this information, I put myself in their shoes and sort of think, okay, perhaps this is why they made that decision. And then that helps me sort of inform, what kind of feedback to give next, right? So that it's actually relevant to, what their decision-making process was given the context they had.
I love that. It's almost like a non-intentional stance. Because I'm the same. When I use a language model, you don't think that the language model has some grand agenda. You just kind of say, oh, well, it's my fault. I must have just put the wrong information in. And people do, generally make reasonable decisions with the information that they have available to them at the time. So I think that's a great way of thinking about it.
Yeah. we're all just reasoning engines processing information, right?
Yes. But we have this weird kind of thing. I don't know, some people say that language models have deception and intentions and motivations and so on. We seem to have that. But do we? I don't know. Yeah, bit of a galaxy brain thought there.
Yeah, I think it's something in the context, right? It's something in the context that makes us behave that way. Like, why does someone lie, right? You should, if you think through, okay, maybe they went through this experience in their life. They, had this sort of reaction when they, did a thing, and so that's sort of motivating. Hey, in sort of their context window, they've distilled those experiences into, hey, I should lie in this situation. And so that's what they've been prompted with. That's what they'll do. Okay,
let's talk a little bit about technology. So I guess the first question is, there have been some really big landmark innovations over the course of the years, like LSTMs and transformers and so on. And, so transformers were invented. with huge help from Cohere, of course, because many of you guys were on the paper. We're still using transformers. Why is that?
I think the simple answer is that it works. I think it's been proven time and time again in the market, in the economy, that it's sort of the most, it's the best architecture. It's the most efficient one. At the end of the day, like, we just want to run gradient descent super efficiently over, some distribution of data. And I think transformers are right now the best architecture to do that. They're the best way to search for the right circuits to learn the data set of the world.
So there's been like some innovation in terms of building on top of transformers. So, there's things like, RLHF, for example, or even process supervision for doing reasoning and things like model distillation and, quite a few things like that. What do you think about, the lineage of things that we're building on the top? And do you think that will just continue?
Yes, I think that will continue. I think, the things you mentioned are sort of like 4 of hundreds of little tricks, being applied to these models to make them, commercially viable. It's going to be, these tiny tricks that bring 10% to 15% improvements here and there, and it all compounds with each other. I think there's much more to be learned from just optimizing these models.
And can you give us any hints on potential surprises in model architecture in the next couple of years? Do you have any insights on that?
I think the models will become leaner. I think we'll be much better at determining, hey, for this set of capabilities, we only need models at this scale. And so, perhaps a small model is good enough for these things. I think generally as a field, as we industrialize the products, we'll stop looking at the models as being, the only thing we sell. And we'll start looking at them as being, just sort of one component of an overall system. And so maybe more generally, the perception of the model will be slightly less than sort of the system that we're building around it.
Yeah, that really resonates with me because I guess at the moment, there's this paradigm of a monolithic model and we spend loads and loads of money up front and, curate all of the data and train it and tune it and so on. And then we don't do anything to it for a few months until we make the next one. And potentially in the future, it could be far more heterogeneous, for want of a better word. And the process of learning just never really stops. And you never really know which particular model you're talking to because it just becomes this big system. I mean, is that? And am I completely off the mark there?
I think it might look something like that. I think it might look something like, there's just more gains to be had tuning other parts of your the other components of your system than just sort of, hey, like, the reasoning engine will do its job. I think at the end of the day, the reasoning engines are quite good these days, and they'll do its job. Like the generative model will do its job. I think what people will notice is like, hey, these other parts of the system that the reasoning engine relies on to actually produce a good answer, they need to be improved as well, right? Like the interface maybe of how we're receiving information from the users could be improved as well. How we retrieve that information, could be improved. So like stuff like re-ranking was a surprising component, right? Like we never thought about it. We thought, hey, we throw things in a database and just have the models search over it, and that'll be good enough. But like a re-ranker is one of those things that's come out of this industrialization, right? Like it's like, hey, it's not good enough to just throw embeddings at the model. So I think there'll be more stuff like that we'll discover. Either new components or components that need to be improved in the system. That's not just focused on the reasoning engine.
What are your thoughts on this potential new paradigm of inference time computation? Are you a fan of that idea?
I think it's really, really exciting. I think it's really cool that, all the flops aren't just spent on backpropagation. And I think it's an exciting new technique. We're excited to explore it more, obviously. And I think it makes a ton of sense. Yeah, that's all I'll say.
Yeah, it's probably secret squirrels, so I can't probe too much. But I'm so excited about it. I mean, would you mind giving me your kind of hot take definition of reasoning?
Objectively, it's given some information you have in the context, produced more, right? I think it produced more context that could be helpful for the next token. That is sort of the most MLE way I look at it, right? Like it could be, sequences of a chess board state, right? Sequences of, like a math problem. Like I think the point is that the model should produce tokens which are helpful for finding the solution. I think that's ultimately what reasoning is. And I think, yeah, it could be applied to, sort of any sequences.
And where does the reasoning come from? So, I mean, obviously there's the base model, there's the RLHF model, and, some folks are, and Aidan told me that you folks are doing this. So, almost like generating synthetic data sets and training the model how to reason from first principles, which is really interesting. And then I guess the model could continue to learn how to reason from the users of your system, and it just creates this virtuous circle. But is there any more you can speak to on that?
I guess one thing I'd like to clarify with synthetic data, generally in the field, is like, it's not just, the model teaching itself a thing. It's mostly, the models are great at expanding data distributions, right? Like distributions of data that you care about. Sometimes the data is super hard to find. And so but you want more of this distribution, you could actually use the model to create more. And so, like when we talk about synthetic data in the field, it's about, you still need the sort of real data, but you're sort of steering the model to create more and more of it. That's definitely being employed in teaching these models reasoning. But really, I think the problem that the field is trying to solve for is, when you sample from these models, you're sampling its thoughts, right? Really, you're giving it chances to, pick the right next token to answer the question. But when we collect these demonstrations from humans, we're not necessarily capturing the human's thoughts. When in the most naive case, maybe like 2 years ago, you would show humans prompts that you're trying to teach the model, and then they would write down the answer. And so all you're teaching the model is, hey, for this prompt, like, here's the answer. But the thing you're trying to teach the model actually is how to think like the human to arrive at the answer. So how did you reason about this prompt to actually arrive at like this perfect answer? That's sort of the more difficult problem to solve for, which is like sort of prompting the humans to actually write down their thoughts in a way that we can optimize over.
Yeah, it's so interesting. I mean, I interviewed Ryan Greenblatt, and he got a really good result on the ARC challenge by doing some chain of thought prompting and then sampling about 30,000 trajectories. And in many cases, one of those trajectories was the correct answer. And he had a post hoc verifier, and he was kind of building this whole reasoning engine. And it's interesting that we can execute code as well. So, the language model can think. It can say, here's a function that generates the nth digit of pi. I can now run the function on a Python interpreter. I can pass the results back in. So, like, when we start to think about these things systemically, it's mind-blowing what we can do. But there is always this kind of thing that at some point the amount of compute is just going to be very, very large, because we're going to be doing so much work potentially at inference time.
Yeah, I think verifiers are a very exciting way to sort of have the model explore a system, generate sort of experiences that it can learn from. I'm pretty excited about sort of where to spend compute that's not just, gradient descent over the internet.
Tell me a little bit about how do you hire people into your team? Like what kind of folks do you hire?
At Cohere, we have a good mix. So I think most folks are from a traditional, background with a PhD, or they're from other labs or something like that, or they worked on something, pretty impressive. I personally really like folks from untraditional paths into AI, just because I also took an untraditional path to AI. So I really look for folks who worked really, really, really hard on a very technically challenging thing. So I think that shows to me like the ability to spend a lot of flops, human flops, on a problem to actually like solve it, right? I think I think that's sort of basically all I look for.
Yeah, that's really interesting. So is that another way of saying autonomy as well? Because I think a lot of the challenge of autonomy is overcoming uncertainty and finding relevant information and being able to make progress and maybe discount things that didn't work. But when folks can do that on their own, without help, that's a really good signal.
Yeah, absolutely. I basically just try to think like, can this person do it better than the AI assistants? Like learn on their own and look for information on their own.
So the entire scene is changing, right? So imagine that you're giving advice to someone who's about 17 or 18, about to go to university, excited about all of this new technology and everything that's going to be happening. What advice would you give to them?
I think it's a very exciting time to completely embrace the technology. Right now, the highest output as a human that you could have is actually just pairing yourself up with these assistants to build whatever you want to build. So completely embracing sort of using these tools, adopting them, learning the quirks of these sort of code editors that are AI assisted. I think it's like the best time right now to be a developer. Like you could learn anything super fast. You could build anything super fast. I would just say like dive deep and don't hold yourself back by, it's good to be skeptical, but like don't, keep an open mind, right?
Amazing. Well, Ivan, it's been such an honor to have you on the show. Thank you so much for joining us.
Yeah, thanks for having me. I enjoyed this conversation.